Hello and welcome to the channel. Regulars might recognise this. This is my 2 metre vertical dipole which I use with the Yaesu handheld. So it's a what's called a flower pot antenna. It's got two radiating elements and the choke at the base, and that is about 0.95 of a metre long, tip to the base of the choke, and it's a 2 metre band only antenna. I've got a BNC on some coax. This is all RG58, the whole thing's one run of RG58, and with an adapter that plugs onto that SMA on there. And as you've seen in other videos, this works really great. So happy with this. I've seen a design online, so I'll just get this piece of paper. Here we are. I found this on the Raynet site. Raynet here in the UK is the sort of group of amateurs who help out with event support and emergency coordination and so on. This is a dual band 270 centimetre antenna, designed by Frank Bremer, PA0FPK, and there's references here going all the way back to 1980, a Townsman antenna, and it's similar concept to this vertical dipole in that it just uses coax with a coil, and there's various bits of bared off coax like we have here. We've got the tip bared off and the braid here acting as a bottom element of the dipole. Here we've got inner conductor, outer, inner, outer, a little matching stub, another stretch of coax, and then a choke. And this is for 270, so I thought I'd have a bash at this one. Might be able to get out on air and test the two together. This one's a bit longer. This is about 1.4 metres long to tip to choke, whereas this is 0.95, but this is dual band, this is single band, so there's payoffs there. So we'll start with this design. Here you can see it's all in millimetres. I'm going to add a little bit to the top for tuning, and I can always come down to that, and I'll do a sketch of this so you can see it in better detail. This isn't the best copy. So thanks to Raynet and Frank. We'll crack on and see how we go. So I've got my trusty roll of RG58. This is the second one I've gone through. Really great for projects like this. Alright for very low band HF antenna feed, if not a long run, but yeah, projects, chokes and so on, but not as your main coax feed. Tape measure, good pair of cutters. So the first thing to do is chop the first piece of coax. We're basically taking off this outer sheath and braid, leaving the inner dielectric and core, which you'll see in a second. And the design is 326 millimeters, which is 32.6 centimeters. I'm going to add a little bit more, so maybe leave that at 36, and then I can trim it back. So we're starting with the tip and working down. It's a bit chilly. I thought it's a mid-February here. It's supposed to be getting mild this weekend, but it's a bit chilly, so this might be filmed over a couple of days, but we'll see how we get on. If my hands get numb, I'm stopping. Right, so I've got this line perfectly straight with the end. It should be 326 millimeters or 32.6 centimeters. I'm going to go to say 35, just so I've got a bit to trim. So holding the coax so it doesn't move from that end, I'm just going to make a little nick. So I've got a little nick, and now I'll trim that off, and this becomes the bared off insulator from the centre core, which you'll see in a second. Note the new workbench, shack upgrade. So I've trimmed round with a knife, cut a line all the way down the coax. I'll split this now, so that will peel off. Right, so trim through this with some good cutters, just nipping it off and leaving the inner untouched. Right, so here you can see we've got this very top section. If I zoom in, so that's the bared off bit. Now we need to go down this coax for 229mm or 22.9 centimeters and make another cut in the outer sheath and the braid. So we're going to reveal another section of inner core and dielectric for section C. We'll come on to that, 361. So there's the cut made, that's 229, and again now we need to measure section C, which is 361, 36.1 centimetres. So this piece is staying in place. That cut I've made nice and straight all the way around, and now we're measuring this to strip off again. So 361 millimetres to come off. So I've got my two cuts. There's one there you won't be able to see, and there's one down here. So I've just got a short bit of blade, and I'm just going to run it down the coax using my fingers, straddling the coax as a guide. There might be other ways of doing this, but this is how I do it. Just getting down, oops, turned a bit. You get a bit of twist sometimes. Just down to my cut, which is just there. So now, if I just make sure I'm right through to the braid, which I am, and then we can ease that out. And then get in, get it off. Just slow down as you get towards the cut, which is just here, just to make sure we've done this properly. Yep, there we go. Right, so top section's all ready. Got that middle section. Now we have to nip this braid off and reveal this to the inner dielectric like that one is. So that's the next step. So there it's bared off at both ends, but now you can find this might slide off if I concentrate it up and make it big enough, or I'll just cut down with the cutters, but I might. Will that slide over there? Yep. There we go. Off. So top bit, next bit B, C, and now we're down to D, which if I look on the sheet, we're here now. So D is a section 291 of solid coax, and we're actually cutting this off with a little bit extra to allow for soldering. So I'm assuming D is actually the protected bit of coax, so I'll cut it a little bit longer to get this bare section, because we need to do a little bit of soldering down here. So 29.1 centimetres or 291 millimetres plus a bit more to allow me to trim it. Right, so that's the main section of the coax. So we've got the tip, this first section of braid, and then that next piece, and then the base, which is a little bit longer. This eventually wants to be 29.1291 millimetres. And what happens here, like I say, I'll do a better diagram than this. Let's see if I can zoom in. So you can see at the bottom of this section I'm holding here needs to be bared off. We need to connect the cores together with this little stub and the braid together as well. So I'll come back to this in a minute. So if you can see here, E is a little matching stub which is short circuited at the end, so we connect the core and the braid together, but not at this end. And E needs to be 36 millimeters long, so 3.6 centimeters. So I'll cut that next. I'll also cut F, which again is going to all be joined on here, and F is 195. So I'm going to cut these a little bit longer just so I can get these ends bared off, and then I'll make the proper cut when I know I've got the ends ready. So E and F next. So for the little stub, which is going to be 36 millimeters long, I'm still on the main reel here. This is the main reel of coax. So I've just trimmed off the end of the coax. I'm going to make this as neat and small as I can. So there, I've taken the inner dielectric off. I'm going to trim this short, this centre, getting the focus, trim that short, wrap these round and basically just have a little dome of solder on there. So this is the matching stub. I've soldered the end and made a continuity test just to check that that is braid touching car, which it is. So here's the bottom end. I'm leaving these tails long at the moment because they have to connect to the end of this piece of coax and that piece of coax as well. So now I've got E done, I'm now going to move on to F, which is this length above the coil, the choke. So this is going to still be the main run. I'm not going to cut this off yet because I don't know how long I need this tail for connecting to the radio. So I'm going to bear off this end of the main roller coax and work my way down from there. I'll measure F, which is 195 millimeters, and then the coil. And the coil, in this case, I'm going to use what I've used successfully before, 9 turns on a 25mm former, and I'll show you that in a second. So F next. Right, so this is the end of the main roller coax. I've bared off the ends, left them too long because they have to be connected to the other bits of coax. So this is the bottom part of the antenna. This is F with the choke at the bottom. So I've marked the 195 length in millimeters. I've put a little arrow on there so I know that that end of the tape is the 195. So now we're going to wind the choke, which is 9 turns on a 25mm former, which is what I've used on the other antenna and works fine. So my former is this wardrobe rail, or it's actually the vertical supports for the worktop in the garage as well. So it's 9 turns round, and if I just get the other one just to remind you what that looks like, off the vertical dipole. So there it is again. You can see how I've used the tape. Oh, excuse me. See how I've used the tape to mark the start and the end. Round, 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 9 turns. This is obviously smaller than 25mm. This is just the pole I carry it on. And then taped up so it doesn't come apart. So all touching each other. We'll do that next. So here we go. I've got 9 tight turns. I taped the start just so it didn't slide off all the way down. I'll now put some tape around this just to hold it temporarily and stop this unravelling. And once it's off, I'll pass some tape through the centre and out and round to keep it all tight. And I'm not going to cut this off the reel yet because I don't know how long I need this to be. So I just need to tape it up. Well, hey, the sun's come out. Here's the choke finished. So 9 turns, 25mm former, so that gap's 25mm in diameter, all taped up. So this is F in the diagram, 195mm. Again, I'll put the diagram at the end. These tails are still too long. Need to solder the centre and the core all neatly to the matching stub and the antenna itself, the rest of the antenna. This is still connected to the roll of coax, so I'll need to decide how long this needs to be before I cut this and attach a plug. So the next step is to join all these together. So I've twisted the main antenna and the matching stub cores together. I'm going to solder them first, attach the coax with the coil on, insulate those, and these should be long enough, these braids, to join up. So I'm trying to make this as neat and as small as possible. You don't want big long gaps. This all has to be quite close. So there, we've got those soldered. Now to snip this off, tin this one up and join it on. So there you can see I've taped up the soldered cores. This stub will be taped to there. I've put quite a bit of tape on there to give it some mechanical strength. Now to join these braids and tape the whole thing up and make it nice and strong so it's not a weak point in the joint. So there you go. Just need to tape this up now and seal it off. Right, done. Now to decide how long I need this tail beyond the choke and attach a plug. Right, I'm ready for testing now. I've got a compression BNC on, a runner coax, so if I'm out in the field I can wedge the antenna pole on a wall or somewhere and get way out of the wind. Choke, matching stub, and as you saw, these are the key points of the antenna. So this is a little bit long by about that much in theory, so I can trim this for resonance on 2 meters. My analyzer will work to 2 meters, but it won't do 77, so I'm going to have to use a bit of SWR checking on 70 and antenna analyzer on 2, or I could use the SWR on 2, but I might as well use the analyzer if I've got it. So we'll connect all this up and see what happens next. Right, a little bit frustrated because it kept raining. I found a dry spell, so here we go. I've got the antenna, the base, just above head height. It's taped to the top of a 3 meter fiberglass whip, which is the same setup as I use with the vertical dipole. So if you remember, we cut this long, so this should be long, 2 meters, 2 meters, 2 meters. So here in the UK, 2 meters is 144 to 146. Oop. And there's the looking for the dip on this needle here. So 1.1 at 144. So yes, we're a little bit long here. This is going to be an FM antenna, it's vertical, so we want to be 145.5, possibly 145.5, or anywhere in 145. So if I just, so there's the SWR that meter's registering. Go back to the dip. Yeah, just over 144, and yeah, so it's looking good. So I'll trim a tiny little bit off, and we'll just hope 77s just lands right. Bear with me. Right, so this is the top of the antenna. I'm going to cut a tiny bit off. Let's have a look. Get the cutters. So I'm looking at cutting. What's that, about 5 mil? That'll be. I'll give you the measurements at the end, but 5 mil. Right, here we go. I can always add a bit on if I go too far, but hopefully that's what we need. Let's see. Right, so we'll back up the mast. See where the dip is now. Should be a bit higher. Oh, it doesn't move much. About the same. Right, I'll snip a bit more off. Where's the dip? There we go. What's that needle? That'll do me, 1.1. So our calling frequency in the UK is 1455. There. Ooh, repeaters are above it. For receive obviously, but transmit is either side of 1455. So 1.1. Brilliant. Right, here we are next day. It was getting a bit too wet. I had to stop my outside work. I just couldn't do it. So 77s this morning. Using the radio this time, bit of authenticity. The analyzer won't go up to 70, so we've got lots of adapters to get from this SMA through BNCs to PLs to N, and then another adapter out again. And I found this adapter's loose. I have to be wary of that and get that changed. I don't think I've used that one before. So we're on VHF UHF. Turn the radio on. Go up a channel or down a channel. Just check that still. Yeah, 4 watts, 1.1. I'm only keying up a short time. The meter keeps the reading for a few seconds. So 77s. That's the calling frequency. There we are, down one. 1.67, 1.7 SWR, 1.3, sorry I didn't keep up long enough, 3.8 watts with 0.16 of a watt back. So pleased with that. Right, I wonder where the is that in a dip. So just see what that was. 166, 167. So if I go down a few channels, well, down a lot, wherever this is probably repeater inputs and stuff. Right, let's have a look. So we were on 167. Right, so that's gone up 172. So we've gone up one side of the dip. So now if I go higher, if I press and hold that, past the calling frequency, up a bit more, and just check. Yeah, so the dip's maybe a little bit higher. How high can you go? This will all be out of simplex frequencies here, but just trying to see where the dip is. A short key up. Yeah, so it's a little bit higher, but happy with that 167, I think. So just for information there, all the little snippings I made off the top when tuning for 2, and I'll just wrestle this bit of coax flat just to show you how long it ended up. So there you can see that's the tip of the antenna, and it ended up exactly 310 millimeters or 31 centimeters, and that was for 145/500 here in the UK. So for America you're a higher frequency, so you can leave the measurement at the original length or even a little bit shorter and trim for your band. Right, so I've come out of the village. There's lots of skylarks singing. I don't know if you can hear them. Spring must be on its way. So I've just pulled up and I've got the antenna, well, with my coffee there, on the back of the car, just to get some on-air tests, and I've brought the vertical dipole as well. It's one thing getting resonance in SWR, but we want the RF to be coming at a low angle, so that's a key aspect of this. If it goes straight up, you're not going to get much in the way of context on VHF and UHF, so there may be a bit of plane noise. We're not far from the airport. Right, see how we get on.
Zero, Charlie November portable, Mike 0, Kilo, Oscar Mike. Returning to you there, Ian. Power output at the moment is 2% on the 9700. I'm still receiving you at around 5 and 3, 53 over.
Yeah, Roger Lenny, thanks for that. Yeah, you're on a 4, bobbling a 5 occasionally, so you'll get me a 3. Right, I'm just, bear with me while I just swap over antennas. It'll take me about a minute.
Okie doke. Alright, did you get that, eh?
Yeah, Roger, G0 CNN portable. Well, I would say you're about 1 bar bigger, stronger, Lenny, and Dave as well, I would say. I don't know if you get me any stronger, Lenny, G0 CNN portable.
About 2 S points.
Stronger?
Yes. 2 is 0, yeah. I get, it's in and out here, but it's working a lot better. I don't get no interference at all on here.
Yeah, Roger, Dave. Oh, this is an interesting one, because you're a good way away in Hartlepool, so that's an S2, S3 on me.
Yeah, go ahead, Ian.
Yeah, Roger Lenny. Well, you're S6 on here. I'm getting Dave bizarrely, so it must be the noise at his end, but you're S6 on here, Roger.
Oh, Roger, that readability 5, strength 2 to 3.
Right, remember that, 2 to 3, and I'm getting you 6. Right, I'll swap over. Stand by, Dave. Back in a sec. Well, I think I'm getting you stronger, so this must be pushing the RF down a bit, I think, rather than up into the air.
Just check if Dave's getting you. Dave, are you receiving Ian over? Yeah, Ian, it's gone up. It's gone to just over 6 from 3. 5 and 4, 5 and 5, Ian over.
Yeah, Roger Lenny, thanks for that. Yeah, G0 CNN portable. Oh, well, right, so the new one is better on 70, but the other one does work on 70. It's just a fluke. It maybe just throws the RF up rather than down. Right, back in the shack. I made some notes from those clips for both antennas, for Dave and Lenny, receive and transmit, and the conclusion is the original vertical dipole is stronger on 2 meters by about 1 to 2 S points. That's on receive and transmit. But the new multiband antenna is about 2 to 3 S points stronger on 70 sems. So the multiband doesn't perform as well on 2 than the dedicated 2 meter antenna, but does work. and also works better on 70. So the multiband is truly multiband. The other dipole is a bonus on 70, but not maybe something you would deliberately go out for. So success on the multiband, and the dedicated 2-meter antenna still holding its own on 2. And as promised, here's a diagram of the design, and at the end of this video I've got a link to the build of that vertical dipole. Hope you liked the video, and if you did, please like and subscribe, and see you on the next one. 7-3.